I've been playing with my lathe for about a month now, and I've made quite a bit of them, or quite a few improvements. There's more to make, but I'll show you the major ones that I've done. First off is I've changed the mounting plate from the 1/4 inch up to a 1 inch piece of aluminum. And the other thing I did is if you look down inside the lathe chuck, you can see that bolt head. What that is I think it's a 5/16 bolt, or maybe a 1/4 inch, with a big flat washer on it, and that goes into the center shafting. And the washer catches on this aluminum flange. What that does is when I tightened it, it pulls this whole head assembly into the bearing, which also pulls the pulley into the bearing. So it takes the, or puts preload on the bearings, which is something I needed to do. And, oops, sorry, bumping around. And the other thing I didn't expect it to do was it made this aluminum flange and this steel flange act as one unit. So it improved the rigidity dramatically there. Kind of ruins the pass-through ability, but for right now it's a way better way to machine. Made this nice and rigid, much more so than in the last video. Tool post, you can see I shimmed it up to get it to the correct height. I did some stuff here that we'll talk about in a second. Put some hand wheels on it. You can see one hand wheel there, another hand wheel there. This, oh, way nicer, way easier. So I have yet to put bushings in these, so this one doesn't crank as nice, but it's workable. It can make its own parts now at least. I put brass around those aluminum bars, and I also milled down, you can see on this this HDP block, I cut it down on the table saw, and then I put these aluminum bars with brass shim stock over them so that they kind of go under the rails more to provide more clamping force. And I did that on the back as well as the front. Just brass on brass. Now everything is riding on brass, so there's no more aluminum to steel galling kind of stuff going on. Rides much nicer, and it lets me hold this whole carriage down, which was actually one issue I was running into, is the carriage vibrating ever so slightly, and that was ruining some cut quality. On the tool post, you can see I moved it from the back location to the front location. It just makes milling easier, or cutting easier right now. You can also see I have this threaded piece of steel in here, which is tapped, if I can get the focus to cooperate, with a little set screw in the top that holds us in here. What this is for is right now, since I don't have a tailstock, I can take a little, well, I can't because the tool's in the way, but this little Jacob's chuck can just screw onto it, and then I rotate this thing 90 degrees and I can use it for drilling. It's not the best way to go about it because I have to face the part and then use the little marking from facing to center the tool on it. I use this to bore the hole, so it's fairly concentric, but you can still move it lefty-righty. Not perfect, but for right now to get some holes drilled and use boring bars and whatnot, this works pretty good. And let's see what else. What else have I done? Besides tightening things and whatnot, I still have to make my big tailstock. Haven't worked with that yet. But yeah, that's the gist of it. So let's show you how it cuts. Oh, I forgot to mention, I also made this cool little thing. Since I designed this lathe to use insert tooling, or I designed the tool post to use insert tooling, I wanted to try a high-speed steel tool, so I just used this end mill that had broken, and I ground a rough cutting point into it. And I just made a little adapter so that I can use the Woodruff slot in an end mill to lock this in place, and then this just clicks into the standard tool post. I don't have to make any changes, and the height's set right. No change with high-speed steel as opposed to this one, so I'm just using this right now. So let's get something loaded. Alright, I can't find a seam, or can't seem to find a little scrap of brass right now, so this is just a cold rolled steel, half-ish inch. I've been playing around with this too in the lathe. You can see these cuts are actually already made on this lathe, so if everything goes well, we should have the same quality coming off. Everything snug. So let's try a facing cut here. Nothing in there. pretty light cut, but make sure I'm on line. Good. Okay, let's try something a little more aggressive. You still hear that vibration in there. In steel, I find it's still pretty evident. Everything else is backwards hand wheels are hard to get used to. Majority of my work I do is in aluminum and brass and copper, so it doesn't really tax anything, but steel is a little bit of a different creature. That would maybe be like a, I don't know, 30 thou depth of cut maybe. Let's take a nice little skip cut off here. A little too far, but finishing cut. Still getting used to the right-handed. Let's just pop you off the tripod. Ooh, can you see anything? Probably too close. There we go. It's not half bad. Still needs work, but it's a step in the right direction. Facing cuts I can do pretty well on this. Turning cuts I still seem to have issues, especially with really large diameters, like 4-inch diameters. I have a little bit of vibration, so I'm not sure if it's still in the carriage or whatnot. Thankfully, most of my work is actually 3/8 and 1/2 inch, which it does a remarkable job on. Let's, for funsies, throw some aluminum in. Okay, let's pop out steel. Back you come. Let go of the jack. Okay. Let's try something a little bit stick out. It's stinky, so might bounce around a bit. See what happens. Nicely on center. See, with that much cut, I'm getting a little deflection. There. That might be a little too much stick out. I'll be able to tell by the video if it's the whole chuck assembly or if it's just the piece. And I am using a steel insert, so probably not the greatest combo. Backwards, forwards. Still getting me, still getting me. Yeah, not bad. It's not a perfect finish yet, but work in progress. Actually, before I totally call it quits here, I'll show you how the little drilling attachment works. So, first thing we gotta do is I just put that piece of steel back in there to test on. Is just back these little guys off and just get the cutting tool out of the path of the drill. Put the Jacob's chuck on. I'm not gonna drill it with this big of a drill bit because I don't have confidence that it'll do that through steel without getting some serious deflection. Not quite far enough back on this. Nicely. I was actually using this to drill through some aluminum here. You can see my off-centered hole, but that's a downside of using the tool post as your way to drill is getting dead on center is kind of hard. Some turning. You probably can't see anything, but there we go. Just monkeying around, drilling holes in the center and turning, see how small, see how concentric I am. Scrap. And take this, crank this back. See what's going on still there? Cranking. Something around there. If I was smart, I would have used a centering bit, but more just to show you how it works. You can see I'm off center. Anyway, I'm not going to push my luck with it being so off. It'll work in a pinch. If you spend more time setting it up, it works a lot better, but just eyeballing it with a nice flexi bit, that's the results you get.